Okay, so I hope everybody's having a great first day at PyCon Sweden 2019. I'm going to talk to you about how to learn Python, or really anything, effectively. Basically, I'm going to go through 3 learning techniques that you can apply to learning anything. But first, I'm going to tell you a little bit about myself so that you see why I'm telling you about learning. So I'm from the US originally. When I went away to college, I thought I would major in English because I love words, and I love Shakespeare, and I love editing, and I love writing. But when I got to school, I hated my school's English department. So then I needed something else to do. So I did something else I really like, which is music. And I ended up majoring in music. My freshman year, I also took a class on the art and architecture of ancient Greece. Classics is what that's called. And I loved that too, so I minored in classics. My freshman year or sophomore year, I'm not sure, I took a class on Chinese cinema, and I actually really liked that too. So by the time I graduated, I was just short a language requirement from having an Asian studies minor. I have the language requirement now, by the way. So then I did what you do when you have a major in music and some English credits and a minor in classics and an almost minor in Asian studies, and I went to law school. And I became an attorney. I practiced as an attorney for several years. I worked as a law clerk and I worked as a prosecutor. I used to put people in jail. But I actually didn't enjoy that very much. So then I looked for what else to do. What else do I like doing? So for a while, I wrote articles for a website about Japan. This is actually the cover art for one of my articles about shopping in Tokyo. I did not do the artwork. That is not one of my talents and interests. I did that for a little while. Then I started tutoring. And I taught students about as young as 5, and some of my oldest students were in their 50s. And I taught a little bit of everything. And when I say everything, it was math, English, writing, editing, literature, history, US and world geography, and how to take a ton of different tests. So I learned a phenomenal amount in my years tutoring, because to teach something, you have to know it. I love tutoring, but unfortunately, it is not a super stable gig. So about 2 years ago, I looked at, well, what else do I like doing? And I started working toward a computer science degree. I took a class in Java at my local college and some math classes. And then we moved to Sweden, so it kind of got interrupted. Now I'm in a program learning Java again. However, so now you kind of see why I'm talking about learning. I've learned a lot of different things, probably more than the average person. I am still an attorney, so I have a disclaimer. I am not a learning expert or researcher. Those people absolutely exist, but I'm not one of them. I cannot give you the holy grail of learning. I'm not even sure it exists, but that's not what I'm here to do. I'm just going to share with you 3 techniques I've learned. These are tools. Put them in your tool bag and apply them. See how they work for you. So now that I've told you, spent several minutes telling you about myself, I'm actually going to tell you a little bit more about myself. I'm going to give you a set of related facts, and I just want you to try and remember them. Don't write it down. There's no quiz. No one's going to judge you. Just try and remember it, and we'll use it in a little bit. So the best meal I've ever had in my life was tonkatsu, miso soup, and a yuzu cocktail. And it was at a restaurant named Maisen in Tokyo, Japan. So just to repeat, tonkatsu, miso soup, and a yuzu cocktail at a restaurant named Maisen in Japan. So the first technique I want to talk to you about is called distributed practice or spaced repetition. Now, these 2 terms seem to mean the same thing to me, as far as I can tell. Distributed practice is more what it's called in the learning research. Spaced repetition is more what normal people seem to call it. So if you go looking for more information about it, search for either of them. But if you search for distributed learning, that's something else entirely, also a different learning technique. So what is spaced repetition? A lot of times when we were learning, when we were younger, maybe we were studying for a test, what I would do, and I think what a lot of people do, if I had a test tomorrow, I'd spend like 4 to 6 hours today cramming for it. Because if I did it any earlier, I'd forget it. Even now, it's really easy to fall into the trap of, ooh, I'm going to study Python. Let me sit down for hours and do that for a little while. But what we actually know is that this isn't very effective. What is effective is taking breaks. It's taking rest. Still a musician. It's a rest and music notation. So spacing out your learning, spacing out your practice is more effective. Whether that means having multiple sessions a week, having multiple sessions a day, but take breaks. Now, when I say whether that means, these are some of the algorithms that those learning researchers have applied to this. These are 3 of them. This paper that these are from has like 15 to 20 different algorithms that they're all using to try to figure out the optimal time between study sessions and how long to spend in study sessions. Some of you probably know a lot more math than I do, but this to me is not very usable. So what I recommend is experiment. Find out what works for you. Does it work for you to have multiple sessions in a day? Does it work better for you to have multiple sessions in a week? Do you work best taking a break every hour? See what works for you. And the other useful thing is that you don't have to reinvent the wheel. There are apps out there that will do this for you. These are just some of the ones I found when I searched. The only 2 of these I've used is AnkiWeb and Duolingo. Living in Sweden, if you're not Swedish, you may have used Duolingo already. A lot of people use it to learn Swedish. Behind the scenes, Duolingo is using these same algorithms to figure out when to show you content, when to show it to you again. AnkiWeb is amazing. I've used it for years. It's a flashcard system, but they look at these algorithms and apply them. So if you get something right, it'll ask you about it again in a few days. And get it right then, it's going to ask it about in a longer time. So you get that spaced repetition effect, and you're putting it in your long-term memory. So now I want you to think about, do you remember the best meal I've ever had? Don't say it out loud. Don't spoil it for everybody else. Just try and think about it in your head. What did I eat? What did I drink? Where was it? Do you remember the name of the restaurant? This act of remembering is the second technique I want to talk about. Just to review, it was tonkatsu, miso soup, a yuzu cocktail, at a restaurant named Maisen in Tokyo. That act of remembering, of retrieving it, is called retrieval practice. This is the one I find people generally don't know about that is so important. Retrieval practice and spaced repetition have an enormous amount of statistical validity. We know they work. They work in multiple disciplines. They work for pretty much everybody. That said, if it doesn't work for you, don't use it. Tool in your toolbox. So retrieval practice is the act of trying to remember something, which sounds kind of counterintuitive that you would remember something by trying to remember it. But what you do is you try and remember the thing, you refresh if you don't, and then you try again later with the spaced repetition. The way we used to study, a lot of us, was we would look at something over and over. We'd make flashcards and we'd read them over and over. We've actually found that highlighting textbooks doesn't work super well because you just read it, you're not retrieving it. And that passive looking at something does not really put it in your long-term memory very effectively. So how effective is retrieval practice? This was a study done where they gave the participants a group of Swahili-English word pairs. They didn't know Swahili ahead of time. And then a week later, they quizzed them. The 2 groups on the left used retrieval practice. They got about 80% correct when they took the test a week later. The 2 groups on the right had only 1 retrieval. They didn't use retrieval practice. They both got under 40% correct. The difference between the 2 groups, the dark bars are those who got extra study sessions. The light bars only had 1 study session. And it turned out for retrieval practice, it didn't matter whether they had one session or extra sessions, they got 80% correct. For the other two groups, there was a slight improvement on having multiple study sessions, but it wasn't terribly significant. So how do we apply this to Python, to coding? I know a lot of us, and I know this because I volunteer with PyLadies, and I brought it up once at a PyLadies meeting. What IDE does everybody like to use and why? And one of the things that came up was autocomplete. And there were clearly two camps. There was the camp of, I don't use autocomplete, and there was the camp of, you will take autocomplete out of my cold, dead hands. What I would recommend is if you're in the second camp, that's fine. It's a tool, use it, just like these other tools. But sometimes when you're about to hit the autocomplete, stop and ask yourself, what is this going to look like? What is this syntax? Force yourself to retrieve it. Don't passively rely on the autocomplete. The other way I would apply this to programming or anything, when you have your obviously spaced repetition study sessions, good study hygiene, at the very beginning, ask yourself, what did I learn before? Just try and remember it. Remember everything you can about it. Write it down if it helps. But spend some time doing that active retrieval practice. So now I want you to think again about the best meal I've ever had. But this time I'm not going to make you try and remember it. That's the retrieval practice. We've done it. I assume in a week you would all get it correct. But instead, what I want you to do is think about, quietly in your head, what you know from everything I've told you. So the best meal I've ever had, anything else in these slides. I want you to think about what you could assume from that information. Not literally what I've told you. You know I've been to Japan. You know I've had miso soup. That's not the answer I'm looking for. What inferences could you make? And just to refresh, tonkatsu, miso soup, yuzu cocktail at a restaurant named Maisen in Tokyo. So just take a few moments and think about that. Now, you probably will all come up with things that I would never think of. That's awesome and amazing. Brains are cool. One thing you might assume is either she's lived in Japan or she likes it a lot, and it's probably the second one for a variety of reasons. But you know a few facts. You know I have an almost minor in Asian studies. You know that I used to write for a website about Japan. And you know that the best meal I've ever had was in Tokyo. You can put all those facts together and figure out she probably likes Japan. And you're right. This is my favorite place in the entire world, this street right here. This process is something called self-generated explanations. This was the one that I knew the least about when I learned it, and I think it's super useful. Some of us are natural self-generated explainers. We do this instinctively. I'm actually one of those people. When I read about this, I immediately started thinking about the people I knew who did this. And I was like, oh, I think he does that. I think she does that. I think they do that. And then I would go to them and be like, do you do this? And then I realized I'm doing the thing right now. So I'm one of those people, I do it instinctively. But everybody can learn to do it, and it's a very useful technique. So what is self-generated explanation? As the name would imply, it's based on explaining. So here this student has been asked to explain the shape of the graph. And they say, it's curvy, with a higher bit at the end and a rather aesthetically pleasing slope downward toward a pretty flat straight bit. And they continue in that vein. And it's funny, right? But, A, this is not actually an explanation. It's a description. And B, we can actually apply self-generated explanation to it. What do we know about this student? Probably didn't know the answer. Two possible explanations, really, right? They didn't know the answer, or they're the class clown, and they just wanted to be funny. Take your pick. My guess is they didn't know the answer. But explaining things is the basis of self-generated explanation. Both things that are correct and things that are incorrect. So if you go to quiz yourself and you're right, ask yourself, why am I right? Explain it to yourself. If you get something wrong, do the same process. Why is this wrong? What would make it right? What do I know about it? And I'm going to emphasize this next point a few times because it's really important. It requires a leap, a logical inference. You cannot simply repeat facts. So you can guess that I like Japan, but saying that I have eaten tonkatsu is not a logical inference. It's just a fact I've told you. And you must use these leaps, these logical inferences, to use self-generated explanations. The theory, again, not a learning researcher, but the theory, as I understand it, is that when you do these inferences, you're connecting all these disparate data points, and it is more fully putting it in your brain because you are actively making connections. One of the things that I really love about self-generated explanations is it will tell you what you don't know. I call these knowledge gaps. Because when you go to explain something to yourself, if you don't know what it is, then you know you need to figure out something, that there's something missing underneath your explanation. Just taking my time. There, however, are some pitfalls with self-generated explanations. The first is that you need a sufficiently broad knowledge base to use it. If you are completely new to programming, you're not really going to be able to apply this to your Python. If you know another language and you're learning Python, you can still apply this, definitely. Because you can ask yourself things like, oh, this syntax is this way in Python. Why do I think it's that way? What do I think this is going to result in? That sort of thing. But you do need a sufficiently broad knowledge base. So just be really careful about that. It can be very frustrating if you're trying to use it when you don't know things, because you'll find all the knowledge gaps and none of the knowledge. When you're using this, you want to start broad. Start with the big picture and what you do know about, and work your way inward to smaller things and to more detailed topics. Another tricky point to consider. This quote is generally ascribed to Mark Twain, but he didn't actually write it or say it, to the best of our knowledge. I'm from Texas in the USA, so these sentences look really normal to me, but I'll explain what it says after I read it. It ain't what you don't know that gets you into trouble. It's what you know for sure that just ain't so. I'm from a place where we say ain't. It's not what you are ignorant about that will cause you problems. It's what you're really confident about and don't actually know. We all fall into these pitfalls, but if you do this when you're doing self-generated explanation, it will cause massive problems. Because if your underlying assumptions are wrong, your explanations are wrong. So with self-generated explanation, you need a mentor to run these things by, or some way to test it, whether that's a textbook or your code or whatever. So just be really careful about assuming things and running with your explanations. And again, this point, don't be a parrot. Cannot be a parrot. It's a beautiful parrot, but you can't be that parrot. Cannot repeat facts, must make inferences. So how do we apply this to programming? What I would recommend, feel free to try to read this, I just pulled it off the internet. If you think something is going to work a certain way, if you're like, I think if I do this, the code is going to come out this way, go and test it. That's the beauty of programming. You have a creative box there that you can try things with, just like art. So go and test your code, and if it runs, awesome. You know that maybe your explanation is right. That is the tricky part with code, is it could be running correctly for the wrong reasons. You may actually have something wrong. Stack Overflow, fraught with peril, because people there can be kind of mean. And I think there are people who live to point out duplicate questions on Stack Overflow. That's all they do. But it's a great tool for practicing your self-generated explanations. So when you're learning about something, maybe it's Lambda functions, for loops, wherever you are in your learning, some tool you're using, go to Stack Overflow and look for questions about that tool or that technique or that bit of code. Because somebody's going to have posted and say, I'm trying to do a for loop and here's my code and it doesn't work and I don't know why. I think it should work. So look at that and ask yourself, Why doesn't it work? What do I think would make this code work correctly? And then you can look at the answers and see if you're right. That's pretty neat. And remember that you want to apply this both when you're correct and when you're incorrect. So applying it to people who are having problems, great idea. If you use something like Code Wars, you come up with a solution, again, you're going to know immediately if it doesn't work. When it doesn't work, ask yourself why. Try to debug it yourself as much as possible, rather than relying on other tools. As an example, I am not a Python wizard. I've studied Java. My current class is in Java. Python is just unfortunately, just sort of a thing I dabble in on the weekends. But I recently checked, how do for loops work in Python? And I think I looked at the official Python tutorials. And there were the things I expected, for x in this set, print x. I know what that's going to do. But then it said for x in string hello world, print x. And I was like, and they didn't say what the answer was. I was like, ooh, I think that's going to print each letter on a new line with the space in between hello and world. But it's possible that Python applies some kind of space delimiter and it's just going to print hello and world. I don't think that's how it's going to work. I suspect the string is indexed and it's going to go through each index. And I had this thought process. Like I said, I do this self-generated explanation all the time. And then I went to PyCharm and I tested it. And it did exactly what I thought it would. I might not, maybe they're not actually indexing their strings and it's some kind of Python magic. I don't know. I don't know how Python works under the hood. I would have to check with someone who does to know that my explanation is completely correct. But I was able to make a theory and go and check it and see that it worked exactly how I thought it would. So that's my talk. I hope you've learned a little bit about learning. I would put all these things together. So have regular study sessions that you space apart. Spend some time at the beginning of them doing an active retrieval practice. And when you're learning new things, do these self-generated explanations whenever you can. Pause occasionally and ask yourself, why does this thing work the way it does? If I do this, how will this work? So actively apply those things. And just to leave you with some resources, these are some of the articles I used, some of the websites I visited, and then some local resources. So I said I volunteer with PyLadies. PyLadies is an amazing group. If you're interested in Python here in Stockholm, we have a chapter. The Stockholm Machine Learning Club, also a very active group that uses Python. And there's a Stockholm Python user group that I actually haven't done anything with, but they're very active on Meetup. So another great local resource. And I also volunteer with Pink Programming. So if you are not a cisgendered male, Pink Programming is a wonderful supportive group, not specifically based on Python, but these are all excellent local resources. So I hope you learned something.